Hi everybody, welcome back to Stationeers. Okay, so this is episode 2 of our introduction to IC playthrough. In episode 1 we touched on loading and saving, so we introduced you to the IC housing, and the circuit. And what we did was we wrote a very simple code, which comprised of aliasing. We created a loop with a label, and then we're just loading from a lever and saving the value that we get from that to the light. And if we turn this on, it was just this. All right. So if you're brand new, hopefully you've had a look at this, but you probably ask yourself, well, this is all well and good, but I've got a big room. I want more than one light. What's the best way of doing that? Well, episode 2 is going to be about batch reading and writing. So obviously, the functions that we've used, you've got L for load and S for save or set, whatever you want to call it. There are a couple more functions. So we've got load batch and save batch. And this basically allows you to either load from a batch of devices or save to a batch of devices. And we're going to set that up again today. It's exactly the same kind of setup. So we're still staying on like the light example. But with a couple of differences. Number 1, we've got 3 lights. And number 2, we're using a switch, not a lever. And that changes just to show you that you're not fixed to using the lever. Anything that can output a on or off state could be used for this. And in a later episode, we'll go through how you could completely remove a manual input altogether, have the lights come on automatically when you enter the space. But we'll do that another day. So what I'm going to do is I'm going to turn this off, and we're just going to use one code at a time. So let's get rid of all this. We're done with this one now. We're going to leave it there in case we ever need to come back to it. Otherwise, we're starting anew. Same setup. So I've got my computer, got my IC housing on my circuit. I've got my IC editor motherboard in there. Power supply, obviously you wouldn't use this. This is for creative mode only. But this would be replaced by your power generation, whatever it is you've got. Switch and light. And very simply, we want this switch to turn on all these lights. And this specific setup is only going to be using the save batch. We'll do a quick touch on load batch, but for this specific example, you wouldn't really use load batch. But turn on the computer. Obviously, we've only got a single housing, so we know that we've only got one in here. And let's get to coding. So the first thing we need to do is, as we did on the first episode, is we need to figure out what we're writing. Now, we already know the lights. Remember that you can go into your Stationpedia, search for light, and if you scroll down, you've obviously got the on, and that is what we are writing to the lights. And that isn't going to change. We're still going to use the on for the lights. But because we're using a switch, we're just going to double check that. Now, don't forget, if you've got your configuration cartridge from episode 1, you'll know that you can just point at a device and you can very simply just press the switch and look for what changes. And as you can see, it's the open and the setting. Now, it's exactly the same as the lever, the open and the setting. It's just a different device. But basically, our code, if we wanted to write to a single light, would be exactly the same, whether it's a switch or a lever. So, click on Edit. So, if you remember, we alias our pins because we just want to be able to refer to them easily without having to use D0. So, we're going to alias the switch to D0. And what we'll do, just as an example, is we will rewrite our code from the first one. Repetition is key, I think. So let's rewrite our code from scratch, just so you can see, obviously, that, well, basically how we did that. Kind of go through it again, just get it into your head. So let's alias the light to D1. And then we create our label. Always put labels in your code if you can remember. And then what you can do is use these labels to jump back to. Again, we went through this in episode 1. So what we do is we're going to load into R0. So remember, this is the register. These are variables that allow you to store a value and use it later in your code. So we're loading from the switch, and we're going to load its And if you look in your Stationeria again, if you're unsure, always look in here. And we can load either its open or its setting. They both give us the same result. So let's just load the open. And then we're going to save to the light. And then it's the on. Remember, these are case sensitive. Whereas these that we're doing with our aliasing, these are based on whatever you've written. So if I put a capital S here, I need to put a capital S here. If it's lowercase, then you use lowercase. But the logic types are case sensitive, always the capital. And we're going to save to the light the on as R0. So we load either a 1 or a 0, because remember a switch is Boolean, or Boolean, or however you want to pronounce it. So 1 is on or true, 0 is off or false. So whatever that switch is, we're going to save it to the light. And then at the bottom, we're going to jump to start. Which basically this creates a loop, because if you remember, the code works down. But then if you tell it to jump somewhere, you define either a line number or a label. And we mentioned in episode 1, always do a label, because that means I can bring this all the way down here and it'll work. There's no issue with that at all. So if we confirm, and we've got our IC housing, so we're going to execute, oh sorry, not execute, export. And now you'll see that you've got 85 bytes on there, and your code is 85 bytes. So you know that you've got the code there. What we're going to do, we didn't do this last time, because before what we did was we set the pins and then we did the code. This time what I've done is I've exported, but we're going to turn it on without setting the pins. So if we turn it on, you can see it's flashing orange, and it's telling us device not found at line 5. Now, some of these errors may make sense, some of them may not. Basically, it will always tell you where the error is, but that's for you to try and figure out. So obviously, we can see that the error is at line 5. Line 5 is it's trying to load from the switch. The thing is, though, the code doesn't know the switch exists because you have to put it on the pin. We've currently got this pin set to no device. So that's why it's complaining. So as mentioned, always turn off your IC housing when you're changing pins. Get your screwdriver and just set them. So the yellow is what it's looking for. And you only get this yellow writing where it says switch if you've exported the code. If you haven't exported the code, you won't have the yellow writing there. So I'm going to cycle through until I find my switch. And then here we want the light. So we're just going to go for wall light. We've got 3. But for the purpose of this, it doesn't matter. Just pick a light and turn it on. There we go. We now have a light. If I switch this, easy peasy. So that's basically just doing what this did. And obviously I can't turn this light off manually because the code is constantly looping and it's constantly seeing that this is a 1. If I turn it off, I can't then turn it on. That's all well and good. That's exactly what we did in episode 1. But how do we change this so we can turn on all 3 lights? I'm going to turn off my housing. So in the code, we've obviously aliased a light to D1. Now, if I wanted to, I could do this. Alias light 2 to D2. Alias light 3 to D3. All right. And then what we could do is we could save to light 1, the on as R0. Sorry, not a light 1, light 2. And then save to light 3, the on as R0. Okay, this will work. So if I confirm that, look at the chip. So it's currently 85 bytes. If I export, I've now got 151 bytes. So we know the code has hit it. And then all we're going to do, we've got a wall light, and for making this easier, let's label these lights. So I've got light 1, light 2, and light 3. For the purposes of what we're doing, it doesn't matter. I could do this one as 1, this one as 2, this one as 3. It doesn't matter. The only reason I'm doing that is so that I can put each individual light onto its own pin. Otherwise, they'll all be called wall light, and you just wouldn't know which one is which. So for the purpose, we just want them all named something different. You could call one apple, one sky, one car if you really wanted to. But we've got a switch. We've got light 3. And then what we'll do is we'll do light 1 and we'll do light 2. Turn it on. We've got no errors. And now if we do the switch, they're all on. Okay, that's easy. That's just repeating what we've already done. And what you'll notice is we haven't had to load from the switch again, because you load that once and then that variable doesn't change. Because we don't load back into R0 at any point, we can reuse it again and again and again. I could have a gazillion of stuff in here using R0 and it would be fine. Not a gazillion, only up to like 6 or 5 devices based on our pins. In a later episode, we'll cover how to do more devices than what you've got pins. But for now, don't worry about that. So this works. Obviously, it's absolutely fine. However, this isn't efficient. You're wasting pins, and also you're wasting lines of code. You only have 128 lines, 127 here, but don't forget you start on a 0. Whoops, a daisy. Let's bring that back down. So look, you start on 0, and you're also wasting space, because for every character you put in here, so even a space is 1 byte, as you can see there. So try and learn to make your code more efficient in the early days, and it won't bite you in the arse later. So how can we change this? Well, we know that we've got 3 lights. They are all exactly the same device. So basically, we want to tell the code just write to that type of device. Like any light that you see, and obviously this specific light is the wall light. There are multiple lights in the game, but we have 3 of the same. We basically want to tell the code, just save it to all the lights. Easy peasy. So, first thing first is we do not need to alias the specific lights to the pins. Including the D1, it can go. And then we'll get rid of these as well. Okay? So at the moment, all we have in our code is we are loading from the switch. Now, our code doesn't know what a light is. We have to tell it what a light is. So if you go into your Stationpedia, search for the type of light you're using. We're using the wall light. And in here, you have a prefab hash. Now, this is basically the number version of the device itself. So you've got the name of the wall light. From a game point of view, is called a structural wall light. The number for it is this. So I'm going to click on this number. It's going to copy to the clipboard. In my code, we basically need to feed it that number. We need to tell it this is the number you're working with. But we're not going to do this as an alias. We're going to do this as a define. A define is kind of the same as an alias, except this isn't a physical device. You are basically, I think this is called a constant. And I'm not an expert at all, so by me saying I think it's a constant, I'm covering my own arse there. But basically what you do is you define something, and this something will never change. It's kind of like a variable, but it's not a variable you would ever override. You can in more complex codes, but as far as the early code goes, just look at it as you can't change it. So define, we need to give it a name. So let's go our lights, okay? And we're gonna paste that number in. I'm just doing Control V. And what I'm also gonna do is I'm just gonna do wall light. So I've put that in as a comment, just so that I know, because obviously lights could be anything. There are multiple types of lights in the game, but I know that this number belongs to the wall light, and that's just more for me. The code doesn't look at this at all, it's a comment. But now that we've defined this, the code kind of knows, okay, I'm looking for these devices on the network. So this basically just replaces the alias. So now what we need to do is we need to basically save to this. But you can't just do S, because S is looking for a single device. Instead, we're going to do SB. And if you hover over SB, it gives you a little bit of information about it. And you can see there, on all output network devices with the provided type hash. So save batch will save to all of the same type of device based on the hash that you give it. And we've defined the hash here. So I could put in here lights. And as you can see, it's gone white, which means we've obviously got the spelling correct. I don't have to do this. I don't have to define. If I wanted to, I could take this number and I could place this here. All right. But it's not very user friendly. Like if you're having a quick glance at the code, you wouldn't know what this is. You could obviously put a comment at the end of the line if you wanted to. But then every time you were doing something with that, you would have to put a new comment in. So personally, I would just define it. And then you've obviously got the name for it, and the code knows what it's doing. So we're going to just put lights. So the logic type is obviously basically what do we want to do. So what do we want to do to these lights? Well, we know we want to turn them on. It's exactly the same. Everything else is the same on this code as the S that you were doing. So I could put R0 there. So the only difference, so this is obviously the new line using SB. The old line was this. Okay, the only thing that changes is you put a B on for this line. Obviously up here, we don't do an alias, we do a define. That's the only thing that changes here. So let's just tidy it up. So we've basically start, load from the switch. This hasn't changed in the slightest. This line, we've now got a B here. And that is it. So we're going to click confirm. And with our code on, we're going to export. Okay, no errors, it's not flashing. All the lights are still on. But this time, if I turn off the switch, all 3 lights have gone off. Now, obviously, we've still got the lights on the pins. They're not actually doing anything. But what we'll do, just to prove that, is I'll remove this housing. And let's put a fresh one down. Now, I could go through and manually change the pins, but I don't want to do that. So let's put my chip back in there. And if we export this code again, might have to turn this off and on again just so it can pick up the new housing. But yeah, so we export the code, we can see we've got the code on there. Now, when I turn this on, it's going to error. The reason it's erroring is because at line 6, it's trying to load from that switch. And remember, we get an error because it doesn't know what the device is. We haven't put the pin to the switch. So turn it off. Set your pin. Turn it on. Okay, no errors. But that switch is still working for all 3 lights. And it doesn't have to be just 3. You could have however many lights you want to. Obviously, bear in mind performance issues. But that's basically it. We are telling the code, this switch, right to all types of light. So what I could do now is, if I wanted to, whoops, it's easy. I can get my tool. Let's just put on some more lights. That's wrong. And get some cable. And what we'll do is just get this connected. People moaned at me because the screws weren't up. I personally don't care, but there you go. So I've added those codes on. Those lights on. I've done nothing with my code. But look, my switch still works. Okay, because the code is looking for all of the same type of light. If we get a different type of light, so let's go for like a long light. Cable. Right, if I turn this on, that light isn't working because this light has a different hash. So all of this type of light will turn on. Any other types of light that are part of the network will not work. The code does not do anything with them. It doesn't see them. It doesn't care about them. They're not a thing to it. That is basically the save batch. The load batch is a little bit different. Now, it's a very kind of specific use case. Like, you wouldn't use a load batch for this. It doesn't make sense. Like, why would you load from multiple levers to turn on the lights? I don't know. Maybe you've got a use case that you want to do that. Who knows? But let me very quickly set up a couple of extra levers, shall I? So let me get myself some switches. And we're just going to do switches, keep it simple. get some cable, and just get those all cabled up. Okay, so we now have 3 switches on the network. Now, obviously, these switches don't do anything. This one is on the pin, so the code knows to use that one. But what if I want to say all of the lights only come on when all of the switches are turned on? Now, you wouldn't do this. There's literally 0 point to this unless you're doing something really unique and whatever. But for the purpose of this tutorial, I'm just doing it to show you how you do it. You then apply this to your actual use case. So I'm going to say when all of these switches are on or set to 1, then turn the lights on. So let's adapt our code. So at the moment, we're aliasing a single switch. Instead of doing that, let's define the switch. And remember that this, that's not how you spell switches. Remember that this could be anything. If I wanted to, I could put apples in here. It makes 0 difference. That's for me, not for the code. But we're going to do switches, and then we're going to go into here, search for the switch. And we want to get its prefab hash. Okay, let's tidy this up. And then this one, we'll just call this switch. Now, obviously, we've got a red error here because it doesn't know what switch is. Now, let's delete this line, and we're going to go through this step by step because it's a little bit different. So, we are going to load batch. Right, pretty much the same as that. You just put a B on the end. It's a little bit different. So, load batch, and then the register comes first. So what are we loading the value into? So we're loading it into the register. So we're going to load into our 0. The device hash is switches. Again, you don't have to do this. You could just put this number here, but this makes it a little bit more user friendly. If you get to the point where you're running out of lines of code, when you're making something really advanced, maybe you don't do this because it's using a line and you need an additional line, so you would skip that. But obviously, this is a very simple example. Now, what we're going to do is, because we want to load from all the switches, we just need to load something, and that doesn't change. So obviously, if we get our configuration tablet, obviously all the switches are exactly the same. You can see we've got the open, we've got the setting, it doesn't matter. Just for the sake of mixing it up, this time we're going to load the setting. Now, what you'll notice is we've got one more, I don't even know what you call this, but we've got one more section that we need to put something into. It's looking for the batch mode. Now, if you remember, whenever you do a load, this won't work, but let's say we did that. Look, there's nothing else here. That's just a load command like we did in episode 1. But that's it. That's that line done. For a load batch, it wants an additional value. And this is batch mode. So because you are loading from multiple devices, it's basically going to retrieve multiple values. So when the code runs, normally it runs from 1, we just get a 0 or 1. But when we load from this, it's going to get 3 0 or 1s. It might get a 0 0 0, it might get a 0 0 1, it might get a 0 1 1, it could get a 1 1 1. But you're putting that value, or those values, into a single register. So we are basically loading from 3 switches, but we're putting them into a single place. Okay, at the end of this line, you have a single value, a single number. So what do you want to do? Your options are sum, min, or min, minimum, sorry, I couldn't remember, maximum, or the average. Depending on what you want, what your code is doing, depend on which one of those you're selecting. Like it's kind of very use case. So if you had, I don't know, you wouldn't do this with switches, but let's say you were loading from multiple tanks, but you wanted to get from all those tanks, which one has got the highest pressure, you would do the maximum. Okay, so I want to load from all my tanks, but then I want whichever got the highest, I want the value of the highest. That's what that would do. Average would basically add them all up and then divide by how many devices are. So if you've got 3 tanks, all have got, let's say, 30 megapascal, 30,000. It would sum them, so you get 30,000, but then it would divide by 3 because you've got 3 tanks. So you would get a value of 10,000. What we're saying is that all 3 of these switches need to be open in order for the lights to come on. So we know we're going to get a 0 or a 1. Now there's a little bit of maths here, but it's like tiny, minuscule amounts of maths. We know that if these are all on, so we've got a 1, a 1, a 1. Add them together, we get 3. So what we're effectively saying is when the value of these equals 3, turn them on. Okay? If it's a 2, if this one's off, that's a 0, a 1, a 2. So if it's a 2, it's not equal to 3. So these lights won't come on. So because we're just going to do something as simple as that, we're going to use the sum. And that will work. You probably could do average. You could use the average and just say, oh, if the average is 1. Because what it would do is add them all together, divide by 3, you get 1. If you say, for example, 2 of them were on and 1 of them wasn't, you get 2. Divided by 3 is not 1, it's like 0.666667. But to make this easy, we're doing sum. So we are load batching from all the switches, the setting, and then we're summing them together. Now, what we're going to do is I'm going to introduce you to saving to the DB. So this is a bit of a bonus tip. Wherever you have the circuit in is the DB. It's the item that is running the code. Now, you can do housings like what we're doing here, and there are certain devices in the game that you can also put a chip into. We'll touch on that in a later episode. But the housing itself has a setting. So if we search for housing, and it doesn't really matter, they're both the same, right? You have a setting option. What this allows you to do is you can write a value to this. This can hold a number. Now, this isn't needed for what we're going through, but I'm just going to give you this little bonus tip. If you are doing testing and you're trying to figure out how to get a code to work, it's always good practice to make sure the code is functioning as you think it should. So in this scenario, I've got a 0, I've got a 1, I've got a 1. I want to test that the sum is doing, I want to test that that sum is giving me a 2. So what we can do is below our load batch, so we're load batching from the setting of the switches and putting them into R0. I can save, now you've used this in episode 1, so you know what save is, to the DB. So DB, it goes green like a pin, but the DB is the device that your chip is in. And we can save to the setting of R0, okay? So the DB is the housing, and we're basically just saving to the setting of the housing, the value of R0. If I confirm this for a second, export my code. Now, obviously, you can hear things flicking. Don't worry about that for now. But what you can see there on the housing is we've got a state of 2. So we can see that actually that is correct because we've got a state of 1, a state of 1, a state of 0. We're getting a 2. If I turn this switch off, obviously ignore that for now, we can see we've got a state of 1 because this is the only switch that's on. This one is off, this one is off. If I turn them all on, we can see we've got a state of 1, got a state of 1, got a state of 1, we've got 3. So we know that the sum is working. Now, there, obviously you can hear the clicking. That's because our code is constantly turning them up, trying to turn them on, turn them off, and it just isn't working. It's because it's trying to write basically a 3 to the lights, and it's just getting confused. But don't worry about that. This is just because I'm showing you this example. I'm going to leave that line in there, so we can always refer back to it. But basically, what we now need to do is we need to do a check. We want this R0 When that's 3, obviously turn these on. So I'm going to introduce you to another function, and we'll touch on these a little bit later about when we're manipulating values or doing checks on values. But what we're going to do is we're going to do a set equal. So you're getting lots of little things today. So set equal basically says, like, give me a 1 or a 0 if something is equal to something. Because at the moment, what we're doing is we're getting a 3 into R0, and at the moment we're trying to write the 3 to the lights, which obviously isn't working. But we need to convert that 3 or the 2 or the 1 into a 1 or a 0. So we're going to do set equal, and we're going to override R0. Now, you can reuse registers. You don't have to write a code and then move on to the next one, because you've got R1, R2, R3, R4, R5, etc, etc, etc. You don't have an R56. I don't know why it's not erroring. But we are going to reuse R0. Okay, so set equal. The value of this line is going to go into R0. And then if we hover over this, now it's a little bit confusing. But what it does is register equals 1. So that's telling you that this register will equal 1. If A, and you can see here A, so if whatever we put in here is equal to B, which is here. If you see 2 equal signs, it just means equals. Don't stress over it too much. Basically, what this is doing is the register will equal 1. The value of this line will equal 1. If A equals B. If A is the same as this will be a 1, else it will be 0. So very simply, we're going to do R0, 3. Okay, so if R0 is equal to 3, this will become a 1. If this becomes a 2, this will be 0. If this becomes a 1, sorry, not this one. So if this equals 3, this will be a 1. If this becomes a 2, this will be a 0. If this is a 1, this will be 0. If this is a 0, this will be a 0. We're only going to get a 1, a true, an on, if this equals 3. Okay, this equals 3. And that's basically that. So as a test, what I'm going to do is I'm going to move this line, and I'm going to put it down here now. Because don't forget, we're using the same register, so this doesn't change. So we are load batching into R0 from the switches, their setting. So are they on or closed? But it's the setting we're doing, and we're summing that together. We're then checking that this value, so bear in mind that after you've done this, you're only working with the register. At this point, we're not working with the switch anymore. Don't worry about that. The switch, this may as well not even be here. You're working with just the value that you have in here. So then what we're doing is we're overriding R0, depending on if R0 is equal to this number. Don't worry too much about the register being in the same line. Okay, this value doesn't exist. So this part of this line doesn't exist until this has been checked. So you're not instantly gonna, but I'm overriding that, but I need to check that. It's not doing that. It only changes the register when this check has been completed. So up until it's done this will still remain as a 1, 2, or 3. It'll only change that to a 1 or a 0 after doing this. But this will work fine. If you wanted to, if it makes more sense, we could do this. It just, different people will learn different ways, so I'm trying to cover like multiple options. But basically, so we're loading into R0 and we're just summing up the setting. We're then set equal, so we're using another register, so we're using R1, and we're checking that R0 equals 3. So doing it this way means you retain the value in R0, so we could reuse that if we want to later on. And then going forward from here, we would just use R1. Down here, I might want to do something else that then reuses R0. That's an option. But for now, this is obviously another another way of doing it. So hopefully this makes some sense. So we are loading the setting from all three switches. They are being summed together. And then here we are making R1 a 0 or 1 if R0 equals 3. Here, this is just our check. So this is just saving R1, or saving the value of R1 to the DB housing. And then this one is we are saving to all the lights the value of R1. I might be throwing a bit too much at you, I'm not sure. But when it comes to save batching and load batching, obviously, like I said, you're potentially going to get different values from this. And you need to convert that value to something that the receiving device or devices understand. They don't understand a 2 or a 3, which is why we're getting that annoying clicking in the background, which will stop in a second. We have to convert that number to something it understands. So we have to do a check, which is what this is doing. Okay, so again, we're loading into R0 from the switches and summing them together. We're then checking that the sum of those switches equals 3. So each switch has to be on. And then all we're doing here, this line isn't needed. If I wanted to, I could delete this entire line. This is literally doing nothing. And this one is just saving to all the lights, the on, and the value of R1, which is coming from here. Confirm that. Export the code. The clicking has stopped, and the lights are currently on. And that's correct, because as we can see here, we've got a state of 1. And the reason it's 1 is because that is 1, that is 1, and that is 1. So they all equal. Well, they're all summed up to 3, so we know that's correct. If I turn this off, they're all off. Because again, 0, 1, 1. So we add them together, we get a 2. That is not equal to 3. So all the lights go off. If we turn off this one, but turn that one back on, it's still the same. The lights, the switch is only equal to 2. If I turn this one off, and this one off, we've now got a 0. Okay, and you can see there's 0. So that's doing the check that it equals to 3. I turn that one on, still a 0. Turn that one on, still a 0. Turn that one on, equals 1. Okay? Hopefully that makes a little bit of sense. I 100% get it that if you are new to coding, this is probably a little bit like... but... have a play. Try and figure it out. The save batch is easy. The save batch is just you replace the S with a B, and then you replace the alias with a define. That one's easy. The load batching is a little bit more involved because you're going to get a number which you have to convert to whatever the receiving device wants. But remember that whenever you're doing code, when you're first starting out, make your notes so you know what each line is doing. If you don't understand this, have a play. Try min. I mean, what happens if we do minimum? Let's have a look. So what that's going to do is it's always going to give us the minimum value. So if I was to export that code, obviously it's going off. Now, the thing is, the minimum value of all of these is 1. And obviously we're testing that it should equal 3. So you know what? Let's cancel out this line. And let's put this to a 0 and this to a 0. Okay. Now, minimum is... that's not how you spell setting. So basically what it's going to do, it's going to load either a 0 or 1. And it's going to take the lowest number. So this will give us exactly the same output. If I export this code, right, those lights have come on. Because we have a 1, a 1, and a 1. So out of all three of those, the minimum value is a 0. If I turn one of these lights off, I have a 1, a 1, and a 0. The minimum is 0, so that's what it's taking. If I turn all of these off, I still get a 0 because the minimum of all of those is 0. Doing it this way means you don't have to do the math. Okay, you can just load the minimum and then you basically just write that value. Maybe I should have started with that, but nah, I'm not very good at teaching, as you probably told, as you can see. If I turn one light on, I get a 1, but my minimum is still 0. If I turn this light on, I've still got a 0 because these two are 1, but this is a 0. Turn this one on, all of a sudden the minimum is a 1. And the lights understand that a 1 is on, so that would work. Little bit of a different case is if you were loading from something that gave you something other than a 0 or 1, so I don't know. I'm not going to go through it, but say there's something in the game called a dial, and you can set it to a different value up to, like, I don't know, a ridiculous number. Say you could load 20. If you had 3 dials at 20 and you loaded the minimum, this wouldn't work because you would then be trying to write that 20 to the lights and they don't understand 20. So you'd probably get that clicking and it'd just be a bit annoying. But that's the minimum. What happens if we do maximum? So change to maximum, export the code. So at the moment, the maximum is a 1. Okay? If I turn one of these off, I've still got 2 1s, which means the maximum over these 3 switches is a 1. If I turn this one off, they're still on, because obviously the maximum is 1. If I turn this one off, they're now all 0, which means the maximum is 0. So we've inverted the setup. Now all of our switches have to be off in order for the lights to be off. If a single switch is on, it will turn them on. It might be that you want that. It might be that you say, oh, I want to be able to turn my lights on from multiple places. Fine. If I walk into one room and turn the light switch on, all my lights will come on in the base. I might leave the room and turn off the light. I might go into another section, turn on that switch, it'll do the same. So it all depends on your use case and how you want to use this. We may as well do it. We may as well see what we get. This will probably cause some issues. So let's load the average. And let's export that code. So they are all 0, which means the average is 0 because it's doing 0 plus 0 plus 0 divided by 3 is 0. If I turn one light on, nothing happens. But you can hear the clicking. Because what it's doing is it's doing 0 plus 1 plus 0. That's 3. Sorry, no, it's not. That's stupid maths. That's 1. We're then doing 1 divided by 3. So in here, you'll see we've got 0.3333333333. That's doing that because of this. This is that line. The lights do not understand a decimal number. They want a 0 or 1. I'm feeding it a decimal, and they're going, click, 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 click. They don't get it. If I do this, still get the same issue because I've got a 1, and a 0. So I've got 2 divided by 3 is 0.666667, as you can see here. Okay, still don't understand it. Turn that one on, they're happy because you've got 1 and 1 and 1 is 3. Divided by 3 is a 1. It's a number the lights understand. So that works. However, obviously, any other combination of these does not work. Okay, the lights need a 0 or 1. So in this example, you would not use average. But there may be other scenarios that you would use average. So go and have a play, figure it out, and yeah, kind of learn from doing. So that what I'm gonna swap that because the clicking is so annoying. So I'm gonna go with the min because that is the one that used the least amount of coding, and because I've done that, I'm gonna change my code. So takes the minimum from all 3 switches. Okay, we don't need this line, so you know what? I'm just gonna delete that. But we went into a world of like number manipulation there. We'll do that next time. So If you take anything, just take that. We can load batch. We can save batch. Saving is easy. Loading, there is additional steps that you need to do. Depending on your situation, pick one of the 4, and then kind of go from there. You can, and I haven't touched on this, but you can put as like a 1, a 2, or 3 in here. That does work. If you hover over the load batch, you will see 0 is average, sum is 1, minimum is 2, maximum is 3. If I put a 4 in here, chances are it's going to error. Oh, it doesn't error. It's just not going to work. Yeah, it doesn't understand. But this needs to be like 0 to 3 or the words. Personally, while you're getting started, do the words. It makes more sense. Because otherwise, you're going to have to go here and go, oh, what does the number 1 mean? What does the number 2 mean? Just write the full word. Job done. But yeah, so we've kind of touched on load batch and save batch there. Now, probably not the best tutorial kind of showcase thing. I'm not a great teacher. Hopefully I've made some sense. If I haven't, let me know in the comments. Tell me whether that was crap. Tell me whether that was good. Tell me if you want me to try and explain a certain part of that a little bit slower. I'm more than happy to do that. Or if you've got an example where you'd like to see this used, also let me know and I'll put that in. I'm open to criticism. I'm open to praise. If you send me criticism, I'll cry and I'll pretend like I didn't. But yeah, that is pretty much load batching and save batching. So at the moment, we've got 2 kind of examples under a belt. Have a play, see if you can figure it out. If you can't, let me know. Don't let it beat you. Like it's if you don't do coding, then yeah, it might feel like a lot. Just repeat, and eventually you will get it. It just takes time. It might be that the way I've shown you this makes no sense, but there are plenty of other videos on YouTube. Just look it up. Like just Google like load batching or save batching, and chances are you're going to find a video out there that can help you in a way that you understand. If not, I'm happy to try again. So I'll leave that on the screen just so you can kind of see what we did. Again, make sure you leave notes, comments for yourself in there, and make sure you update the comments if you change your code. Otherwise, that will just confuse you in the future. So I'll leave it there. Thank you for watching, and I will see you next time. Bye.